If you guys have done quiz 6, you can give it to me. If you've done quiz 6, you can give it to me now. You guys do question 10, please. It will about until 5 past 1. We do question 1, question Alright, there is a typo in question 10. It should read N, not M. There's no M in the question, right? It should say it's a sample of N independent. Oh, sorry. Sorry, I think this is correct. Sorry. It's my mistake, guys. It should be, this is correct, it's M, yeah, it's correct. It should be M and P, it's correct, yeah. There's no need to correct it, okay. M and P. This is M, P. Right? Sorry for being stupid. Right. So let me show you. If you haven't done it, so you have P hat. You guys listen, please. Right. So you want to find the bias, right, which is the difference between these two, right? So this is expectation of X bar Right? Okay, guys. Now, what's the expectation of x bar is 1 over n plus 2 times the expectation of 1 over n times the sum of xi, I from 1 to n, plus 1 outside minus p. Right? Now this is 1 over n plus 2. If you take the expectation inside, you get yeah. Now I'm sure all of you know what's the expected value of a binomial MP, right? So it's gonna be sum I from 1 to n of m times p. Right, so this will be if you divide this, you get 1 over n times n m p plus 1 divided by minus p, right? Okay, now clearly what you have is m p plus 1 divided by n plus 2 minus p, and this is clearly not equal to 0, right? Hence, so this implies that p hat is biased. All right? Is that I mean, those of you who did quiz 5, it should be trivial. I mean, I'm sure all of you did quiz 5, yeah, correctly. So you should know how to do this easily. Yeah. Now, that's the first part. The second part. Are you guys okay? The second part of the question is to find the variance of p hat. So the process is similar. So to find the variance of p hat, you have variance of yeah, and this you can write as, let me take this away. There's no need to copy, guys. I will put this online after the class. You can write this as the variance of x bar divided by n plus 2 plus 1 divided by n plus 2. Now the second term is a constant, so it doesn't affect the variance. So this would be the same as 1 over yes. You see that? Because this has no effect on the variance, and you should pull the constant outside, it becomes the square of n plus 2. Okay? Now taking the variance inside, it becomes right, this is what you get. Right, now I'm sure all of you know that the variance of a binomial with parameters m and p is m p 1 minus p. Right? So therefore the answer is m p 1 minus p divided by n plus 2 squared n. Right? And this obviously approaches. Alright? Okay, can you now do question 9, please? Question 9, if this is clear. question 9 is also on bias. You shouldn't have problems doing it, but I did. Yeah, it's only bias in the value, so. That's okay. I'm done for 6, so. Thank you. Thank you. And anyone who wants to handle quiz 6? Oh, has everybody signed this? Sorry. Quiz 6, guys. Anybody else hasn't signed? Anyone else? All right, guys, had you done question 9, please? It's easy, guys. Given what you've done in quiz 5, it shouldn't be difficult for you. All right, I mean, unbiased means what? If an estimator is unbiased, then the bias must be 0, right? So you want to compute the bias. You want to compute the bias and set that to 0. So if you take it to all right, now let me check your memory. What's the expected value of a uniform 0 theta? This one here. Expected value of xi.
Theta over 2.
Theta over 2. Yeah. Okay. So you get k over n times n theta by 2 minus theta equal to 0. And this implies k must be equal to 2. So k is 2. So that's the answer to the first part. The second part is to find the variance. Alright, so to find the variance of theta hat, you take the variance of 2 times x bar, because k is 2, right? And pulling 2 outside, it becomes a 4, right? So it's 4 times the variance of 1 over n okay. Now taking the variance inside, it becomes 4 by n squared times the sum of the variance of xi. Now I'm sure you know, the formulas for the mean and the variance are given in the handout I gave you on the first day of classes. You must have a copy of it. If you don't have, just let me know. Alright, so the formula for the variance is theta squared over 12. If you don't know where this comes from, just please look at the handout I gave you on the first day. It gives you the formulas for the mean and the variance of all kind of distributions, including the uniform. Right? So right, this is what you get, and this is equal to theta squared divided by 3n. Right, and this clearly goes to 0. Clearly it goes to 0 as n approaches infinity. Right? Okay, guys. So that's question 9. Can you now do questions 8, please? 8. Where is it? I don't know. Where did I put it? Hello, sir. Yeah, it's over there. You guys do question 8, please. Now. Anyone else who hasn't signed, they turn the sheet, let me know.
Is that okay?
Okay.
We did that when we talked about the chi-square distribution. Remember? Yeah.
You guys got question 8, guys. Because xi is known, right? So the replacement of xi squared is sigma squared. Because xi is known. Because remember the variance of x is sigma squared. Therefore, x squared. Alright guys, let's say, I mean, you can do this question in different ways, but one, I will give you an easy way of doing this question, number 8. This is an easy way of doing it, right? So you have see, right? You have this, right? And we want to show that that this is an unbiased estimator for some values, k. So you need to compute the bias of this guy here, right? Which is this, and this is the expectation of k times All right. Do you guys remember the chi-square distribution we did some time ago? I mean, 3 weeks ago or something. Do you remember or what? Now, one of the properties I gave you in the class is the following. I'm going to use it now. All right. The property is something like this. If you I don't know whether you remember this or not, but you should look in the scan note. You will see this. You see what I've done? I have multiplied by sigma squared and divided by sigma squared. So I haven't changed anything. So this is now let me ask you, let me test your memory. What do you know about this? What distribution does this have? I mentioned this in the class, guys. What distribution does this have? Have you been reading the notes, guys? This guy here has a chi-square distribution with n degree of freedom, right? And that's from the notes. That's why it's important that you revise the notes. That's why I give you the quizzes, guys. Now, do you remember the expected value of a chi-square? I proved that in the class. It's n, right? And this is equal to 0 if k is equal to 1 over n. Alright? So that's the answer to the question 8. It's also asking you what the sampling distribution is, but we have already answered that. The sampling distribution, because remember 1 over n times this is simply is this, okay, and this guy we know has a chi-square distribution with n degree of freedom. So what you have is a sigma squared by n multiplied by a chi-squared variable with n degree of freedom. So this is the sampling distribution. Sorry, this is the sampling distribution of what is given. Right? Is that clear to all of you or not? Yeah. So we just used a couple of the properties that we learned in the course, right? Okay, the first property is that this has a chi-square distribution, and the second property is that the expected value is equal to n. Alright. Can you do the next one, please? Which is next one is question 7. Can you do question 7, please? So question 7 is also uses the chi-square distribution, which we talked about a while ago. I know. So remember the let me sit down. So you have a random sample of size 10 from normal 4836. So first part is to find the probability that this sample variance lies between 25 and 60, right? Now, do you guys remember what a sample variance is? What's the formula for this? What is the sample variance? It's 1 divided by n minus, what is n minus 1 here? It's 9, yeah? Times right, this is the formula for the sample variance. Yeah, I gave you some time ago. 1 over n minus 1 times this. N. So n is 10, so n minus 1 is 9. Okay? So now the next thing I'm going to do is I'm going to multiply everything by 9. So you get 9 multiplied by 25 less than 9 multiplied by 60. Alright? Okay, the next thing I'm going to do is I'm going to divide everything by sigma squared. You see in a minute why I'm doing this. Now the sigma squared in this example is 36, right? So I'm going to divide everything here by 36. Divide this by 36. Do you see why I have done this? Because can you say something about this? What distribution? I mean, just checking your memory, guys. Once again, what distribution does it have? Cascade with what's the parameter degree of freedom? Come on, guys. I gave you this in the class. Cascade with. Don't you remember? I'll write this down if you don't remember. You should have something like this. I mean, if you look up, right, this as a chi-square distribution with n minus 1 degree of freedom. Get another box. One more box. Right? This is a result I gave you in the class. Do you remember? Or not? Anyway, if you look in the scan notes, you will see this. Right? So what you have is the probability that this is what you have, right? Now you can compute this using, obviously you need a computer to do this. So in R, for example, if you're using R, you can compute this as follows. So P df stands for the degree of freedom, right? All right. So this is how you do the first part. The second part is this clear to all of you, by the way? Yes? No? You just need to remember these facts, guys. I mean, I know we did this a while ago, but you just need to remember these. I mean, okay? Okay. Right, so that's part one, and part two of question 7 is like this. So part 2 is asking what is the sample size, so that the probability that s squared is greater than 20 is 0.9. Okay. Now remember, s squared is once again the sample variance, so this is the same as saying that and this is the same as saying that the probability that is 9 times 20. Okay, and now you should divide both sides by sigma squared, which is 36, right? Oh, sorry. I made a mistake here. We don't know the sample size, so this should be n minus 1, guys, not 9. We don't. I mean, this is n minus 1, not 9. N is the sample size, guys. N minus 1. Okay. Okay, now if we divide both sides by sigma squared, which is 36, okay, you get this. Okay. Now we know from the result that I just mentioned that this guy has a chi-square distribution. There's a chi-square distribution with n minus 1 degree of freedom greater than you can simplify this 5 sorry, did I say 4? Yeah, 4, 9. Okay. Now to solve this, you need to use, you can solve this equation. So right, you can't solve it by hand. So in order to solve this, so what basically you need to solve this equation for n is the sample size, right? And you have to use a computer program like R to solve it, right? Okay. Can you do question 4, please? Now question 4, you can skip 5 and 6. Can you try question 4, please? Question 4. Anybody wants to handle question number 6? You can do so now. You should have done quiz 6. You can give it to me now. Alright, question 4 is something we did a while ago. So let me see how we can go about it. Alright, so you have a sample of 10 from a normal distribution with mean 20 and variance 3. Okay, and you have a sample of 15 from a normal distribution with mean 20, also the same. Now let me check your memory, guys. If you have a sample of size 10 from this, what distribution the sample mean will have? Come on, guys. It will be. You forgot. No. Okay, let me write down in the box. Maybe let me write down a box here. Okay, if I think I gave this result to you some time ago. Right? If you have IID normal, right, then X bar, the sample mean, has a normal distribution also with parameters. Do you remember this result or not? I think I gave it to you. All right, this is a result, right? So because of this is 10, 3 divided by 10. So it's 20, rather 20, comma 3 divided by, and similarly x for the second sample, you should call the sample mean x bar 2. It will be normal with parameters 20 and 3 divided by 15. Right? Okay, guys. Now the question is to find the probability that the means differ. So we want to find the probability that the two means differ in absolute value by 0.3. Okay? Okay, now before I do that, this is the same as saying, right? Come on, guys, just give me a sec. I know you're in a hurry to go. Just be with me, okay? Now what? Okay, you have the first sample mean which has this distribution, the second sample mean which has this distribution. So what is the difference? What distribution will the difference have? Will the difference, because these two are independent, the difference will also have a normal distribution. Did I not? Okay, so it will be normal with parameters 20 minus 20 is 0, and the variance will be 3 over 10 plus 3 over 15, greater than 0.3, yeah, and plus the probability that normal 0, 3 over 10 plus 3 over 15, less than minus 0.3. Right, and I'm sure from this step you should know how to work out, right? The next step would be to standardize them so that this reduces to normal 0, 1, and this reduces to normal 0, 1, 2, and then work it out using tables. Do you guys know how to proceed from this step? Yeah? I assume you would know. Otherwise, you can look up the solutions online. The solutions for all the problem sheets are online. So you can, I mean, in the first website. So you should know where to see. See you guys. If you have any questions, just email me, okay? Email me or Zoom me 24/7. Hey, here am I.
For the draw. Why is the mean 20?
Does it not say that? Yeah, it says 20 here. They're both 20 from the same distribution. Just the sample sizes are different. How are you, sir?
I have a question for you. 35 is like this height. We got two rings and both sides. Two motion. And I combine those together. And if there is, you're getting kind of like 14 into a is like is a 0.65. And you want to calculate like the differences between the two rings and the that's a I did it in like
Yeah, you need to use the yeah, you need to use the central limit theorem to do it. Use the central limit theorem. Hello. That's a different plot.
like two uniform.
They're not uniform.
Wow.
So here we are talking about proportion. It is binomial. It's more like binomial distribution. You have to use the central limit theorem to compute this problem. Yeah. Yeah, but you can, if you have more questions, you just send me an email or Zoom connect me on Zoom. Yeah, or you can come and see me.
There's one in my spot and it's got like blue.
Hello guys. You enjoying the classes here?
Yeah.
Hey, Ken, how are you?
Fine, yourself?
That place is incredible.
What was that?